Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Gaussian River College in Sacramento, California. This is yet another video in a series of videos on solving systems using Gauss-Jordan elimination. And you should have already watched the videos on the derivation of Gauss-Jordan elimination, solving 3x3 systems and 4x4 systems using Gauss-Jordan elimination. And I just did a video on what happens if you have infinite solutions. Here's what happens if you have no solutions. Again, as I said, with the infinite solutions, you should always remember that your augmented matrix represents a background system of equations. So if you end up working with an augmented system and you get a bunch of zeros in one row equals 3, that tells you that 0x plus 0y plus 0z plus 0w is equal to 3, or in other words, 0 is equal to 3, which cannot happen, and therefore there's no solution. This is actually the easiest of the cases. If you ever arrive at something like this in one of your rows, a bunch of zeros equals, with an augment on the right-hand side that's non-zero, then you know you can stop and you have no solution to your system. And that's all that really needs to be said here. We can go ahead and try to solve this system, but you kind of know the punchline because I've just told you. So let's go ahead and set it up. 1, 4, and 2, -1, -8, and -3, 3, 32, and 11, and then finally 3, 24, and 4. Generally speaking, when I see a system like this with these large numbers, I get a little intimidated because I think, man, these are terribly large numbers. But don't be intimidated. It's actually not bad. All right. First thing I'm going to do, actually, there is a little bit of pre-work you could do here if you wanted to. I haven't mentioned this as a step in any of the previous videos, but I might as well say it here. If you have an equation where everything's already obviously divisible by a number, go ahead and divide that equation by that number. So I can pre-work this system by saying, you know what, I'm going to divide this entire row by 1/4. That is totally legit. You can absolutely do that. If you did that, you get 1, -1, 3, 3, 1, -2, 8, and 6, and then 2, -3, 11, and 4. It just makes the numbers a little bit easier to look at, honestly. Now we're going to go ahead and use that main diagonal element that's already a 1 and kill off everything down below with that main diagonal element. So I will take the opposite of row 1, add it to row 2 to become the new row 2. And simultaneously, I will take -2 times row 1, add it to row 3, so I get a new row 3. Let's go ahead and draw this out. The only thing that's not changing is row 1. It's going to be 1, -1, 3, and 3. But everything else will change. So I'll take, again, the opposite of this row, and I'm going to add it to the second row. So that's a -1 plus 1, or 0. -1, or 1, -2, is -1. And a -3 plus 8 is a 5. -3 plus 6 is a 3. All right. And now I'll go ahead and take, let's see, -2 times this top row and add it to the third row. So that'll be -2 plus 2, which is 0. That'll be a +2 minus 3, which is a -1. That is a -6 plus 11, which is a 5. You can see, by the way, these are aligning, right? You can see that bottom row looks to be becoming the second row. And then -6 plus 4 is a negative 2. Well, they're not identically the same row, are they? One thing I will also do here is I'm going to quickly multiply row 2 by a negative 1. So negative 1 row 2 becomes new row 2. And that just means I'm going to erase negatives and throw negatives on here. All right, that's just a real quick thing you can do. Now I'm going to go ahead, since this is already 1, I'm going to use that to kill below. Let's go ahead and do that. And I'll write the instruction here. Row 2 plus row 3 becomes the new row 3. Remember, rows 1 and 2 are not changing in this process, so they just become like this. 0, 1, negative 5, and negative 3. And let's see, row 2 plus row 3 is 0 plus 0, 1 plus negative 1, negative 5 plus 5. Ooh, that's kind of nice, right? And then negative 3 plus negative 2. And here is the issue, right here. Actually, this entire row, technically. That is telling us that 0 plus 0 plus 0 is equal to negative 5. And that cannot happen. So this is a contradiction, which means that we don't have any solutions to this entire system. Applies no solutions. These are kind of the nice systems when you get no solutions, because when you're using Gauss-Jordan elimination, you arrive at an answer really quickly. There's just no solution. So this system is inconsistent. And that's all you have to do.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much, that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.